Okay, I wanted to do a quick video. This is Lindelof videos. I want to do a quick video on properties of logarithmic functions, otherwise known of natural log functions, otherwise known as ln of x. I want to remind you of a couple of things that ln of x. So we have ln of x. Ln of x is actually from Euler. It's logarithm natural, the natural logarithm. He was Belgian, I think. Anyway, so he comes up with this idea, and it's based on the number e. So another way to translate this would be log base e of x. So either way, you want to see this ln of x or log base e of x, whatever is most convenient for you is fine. Also, remember this, that when we use any logarithmic function, this is crucial. When we take any logarithmic function, the base, you got to really hear me on this, the base is always a positive number not equal to 1. Positive number not equal to 1. So it can be rational, it can be a fraction, but it can't be a negative number. And if you think about this, because of that, you can never get back, you can never multiply any series of positive numbers and ever get a negative number back, right? So we have to think about that as in our domain, that the domain of this function can never be negative. So we say, well, the domain will be 0 to infinity. Please think about this interval notation here. When you have rounded brackets on your intervals, that means these values are not included. If the brackets look like this is saying these values are included. I'm saying that 0 is not included, and of course I'm saying that positive infinity is not included. So something to think about. So we have this domain here. We also know that the function is continuous and always increasing. So we have a continuous function, so our function is continuous. Think about what continuous means. Continuous means there are no breaks in the function. There are no holes. There are no gaps. Here we could have a function that looked like this. This is not a case of a log function. We could have a function that maybe did this, and then maybe it does this. And it has this place in between where there's a gap. This function is non-continuous from here to here. So we know that log functions are continuous. And we also know, thirdly, that this function is always concave down in this form. It seems like really stupid stuff that I'm going over, like not a lot. You're like, what the hell did I just waste 2 minutes of my life for here? These ideas are so fundamentally important that if you don't get them, if you don't get this idea, you're going to have a really hard time with integration in calculus. So I just wanted to take a second and go over this. If you have questions or comments, please let me know. If you haven't already subscribed, please do. And this may seem like a silly video, but I hope that you're taking the points, these few points of this thing, really seriously. All right, thanks for watching.